Hello everyone, and welcome to this final episode of our video series concerning the CFX solver. In this video we will see and learn about the three main methods that are available for us to see the wingtip vortex. For this you have to wait for the solution run to finish, and once it's over, just double click on the results icon here and this window should open. Then just deselect the wireframe and select the wing so that you can have a better view of it. And then let's get into the three main methods. The first method is to create a vortex core region by clicking on location, vortex core region. Give it a simple name, and now we can see that we have here the method, and we can change it to Q criterion. Just apply. Okay, so maybe decrease a bit the level value. Let's try this. Okay. So the main flaw about this representation is that you don't really have the end on the actual value of the Q criterion that you're looking at. I mean, what you should also be aware of is that your number of elements is very small. The domain you're using is not adapted, so the values that ANSYS is going to give you are not to be trusted. So it's just a matter of playing with the values, but you shouldn't focus too much on what values ANSYS gives you. So here, so you don't really have the end on the actual value, which can be bad for comparison sakes with other configurations. The other method is so you go into location and create an isosurface, which we're going to call QCriterion2. Here in the variable, you just click the three dots, go into derived, vortex core, velocity invariant Q, and now once again you just play with the values, and you should also see the wingtip vortex. So the main flaw about this method as well as the other one is that it's just a constant value of the Q criterion that you're looking at, and you don't really have the evolution of this value. That's it. And the principal advantage of this method compared to the previous one is that you can compare two different configurations just by putting in the same value. So this is quite good. For the last method, its principal advantage is that we can see how the Q criterion and so the vortex strength increases, evolves in the space. But the main drawback is that it's only in a two-dimension plane, so that can be good to have a glance of how the vortex strength decreases with the length. For this, just go to location, create a plane, an XY plane, put it at the wingtip vortex, maybe a bit further away. Create it, hide it, and now create a contour on plane 1. The variable should be the Q criterion, this one, and you should also specify the range. The minimal value should always be 0, but the maximum value, you can just play with it and see what works best. And the number of contours, just put 20, for instance. And now you can see that the Q criterion here actually evolves. The with its distance from the wing. So the further away from the wing, the lower the vortex strength. So you can have the evolution of the vortex strength with this method. You can also change the plane definition. So maybe take it farther away from the wing. Okay, and you can play with the distance. You can, for example, also take it on the wing. So yeah, you can. There's very much parameters that you can play with and see how the swirling strength actually evolves. And so these were the three main methods to visualize the wingtip vortex. And this also marks the end of our video series. So if you had any questions, or if there's something you missed, feel free to rewatch the videos, pause them, and it should be fine. Okay, bye.